Hey, Pup.
Hey, Rack.
Hello.
Oh,
If factoring were polynomial, everyone knows that factoring is not polynomial. We're not here to argue, but we're going to discuss the kind of code we would write if factoring were polynomial. We'll first talk about the status of the project. We will then discuss two problems that took around 2 years to solve. We will mention some concerns about the algorithm, and we will discuss some of our future efforts. The status. Currently, all of our factoring unit tests pass. We can factor all 2-bit numbers and all 4-bit numbers, which use 16 and 64 binary decisions respectively. The algorithm is polynomial. Factoring is on the order of n to the 16th. This is too slow to be practical, but fast enough to be amusing. And the code that we would write is now available online on our GitHub repository. Our approach is based on the Hadamard population equation, which is for all binary vectors a and b, the fast Hadamard transform of a dot product the fast Hadamard transform of b is equal to n times the population of a intersect b. We proved this nearly 2 years ago. The equation enabled us to build equation butterflies, which are dynamic programming data structures that enable us to express constraints between the bit values in a vector. Note the constraints are the meanings of the butterflies, and butterflies are the implementations of the constraints. The equation butterflies have always worked in the sense that they always correctly revealed whether a Hadamard vector was valid or not. Our first problem was merging the constraints or merging the butterflies. Our original constraints from 2 years ago had the form Cij may not equal 2. In other words, bit I and bit j may not both be true at the same time. So for example, constraint 0, 2 not equal to 2 means that if we intersect b with the vector 1, 0, 1, 0, then the population of the resulting vector must be in the set 0, 1. This is our first attempt to understand what constraints and butterflies should mean. However, we came to realize that this constraint embodies two different equations. The population must equal 0 or the population must equal 1, which express two different ideas. And unfortunately, merging butterflies which express two different ideas proved difficult. We now believe that each constraint or butterfly must match exactly one population. So for example, the constraint 0, 2 equals 1 means that the population of b intersect 1, 0, 1, 0 must equal 1. Different constraints refer to different bits within the vector and different populations. And we have found we can combine different constraints to represent both factoring and packing problems. Once we redefined factoring and garbage can packing in terms of the new constraints, lots of things began to work. The second problem was extracting valid Hadamard vectors from the merged butterflies. We had presumed that wringing out all invalid states in the dynamic programming would leave only valid Hadamard vectors as a result. However, the algorithm often combined pieces from different valid Hadamard vectors into an invalid result. We realized that all root Hadamards must derive from the same leaf Hadamard vector, and that all leaf Hadamards must derive from the same root Hadamard vector, all at the same time. We ultimately had to come up with an idea that we call canonical Hadamards, so canonical spline values and canonical population values, to constrain how Hadamard values vary together. A first concern is the difference between factoring and garbage can packing. Our factoring tests succeed, but our garbage can packing tests often fail. We do not yet know the cause. Possibly this shows the difference between the natures of factoring and garbage can packing. Most likely, this also reveals a bug in the algorithm. Another concern is that the algorithm needs more analysis. We have a rationale for the extraction process, but not a proof. Extraction might not be polynomial, even though we believe it is. At worst case, it is 2 to the log n times square root of n, which improves on exponential significantly. Another concern is performance. Testing 4-bit numbers works, but testing larger numbers is impossible for now. We plan to produce 2 videos that explain the 2 main problems that we encountered in greater detail. We also plan to continue working to fix the garbage can packing problem and to improve performance.